Hello students, in today's session of Mechanical Properties of Solids, NCERT Chapter 8, where the basics on elasticity will be cleared through illustration. In earlier session, we have discussed what is Young's model of elasticity, what is Hooke's law, what is stress, what is strain, which you can review on Sethi Swift Learn. In today's session, we are going to discuss types of elasticity, that is Young's modulus, bulk modulus, modulus of rigidity. How they are defined? All concepts are being cleared through illustrations. Please go through the complete session, going to be very important. Now let's start with the question and concepts. Question is, if the ratio of diameters, length and Young's modulus of steel and brass, Y shown in the figure are P, Q, R respectively, then the corresponding ratio of increase in their length would be, four options are given to you, one of the option is correct. This is the figure. This is steel wire, this is the brass wire. Right? Concept applicable and solution. Now, what is Hooke's law? Hooke's law. Just start from the, before start of the question, some basics will be discussed. Stress proportional to strain. Stress that is equal to E, that is strain, is the modulus of elasticity. This is of three types. In this case, we will discuss only Young's modulus of elasticity. E equal to Y, Young's modulus of elasticity. That is equal to stress upon strain. Stress is F upon A delta L upon L. That is FL upon A delta L. Right? Now, in this case, this stress is known as longitudinal stress. This is of two types. One is this and another is this. In this case, length increases. In this case, length decreases. Means tensile strength. Tensile strength is when two equal and opposite forces act along the length in this direction. When length increases, that is the tensile stress. When two equal and opposite forces act along the length in this way and length decreases, that is known as the compressive stress. Right? Now, in this case, Young's modulus of elasticity equal to stress upon, that is Y equal to F upon A, FL upon A delta L. This is the fact. Right? Using this concept. Now, let's start with the solution. Now, solution of the question is, according to question, given is diameter, length and Young's modulus. Diameter, length and Young's modulus. Diameter, length and Young's modulus. Steel over brass. See, LS over LB, Q and YS over YB R. As we know, Young's modulus is given by F upon A delta L upon L. That is FL upon A delta L. As A equal to pi by 4 d square, that comes out to be F4 FL upon pi d square delta L. as you have to find delta L, so taking delta L on the left hand side, 4FL upon pi d square y. Now taking the ratios, delta L S over delta LB will be equal to 4 से 4 कट जाएगा, पाई से पाई कट जाएगा, FS over FP, LS over LB, DB over DS and YB over YS. In this case, this is directly given, this is given, this is given. FS will be and FB will be. FS. FS is steel wire is under the 2 plus 3, 5. 2M plus 3M into G, that is 5 MG. And brass is under the press of 3 MG only. That is 3 MG. Substituting values, that comes out to be FS over FB, 5 mg upon 3 mg, LS over LB, LS over LB, LS over LB Q, LS over LB Q, dB over ds 1 by rho, 1 by P, and YB over YS 1 by R. On simplification, we get mg se mg goes 5 pi d square, that is pi d square, that is pi d square. This will become p square. This will become p square. Right? So 5 q upon 3 p square r. This is the answer on simplification. On simplification, let us see the answer. 5q upon 3p square. 5p upon 3p square. That is the answer. Correct option is D. Right? Next question. Before start of the next question, I will request that these concept killing videos, which are very useful for 11th standard, 12th standard, CBSE board, state boards, JEE, NEET, CUET and other entrance examinations, which you can review on Sethi Swift Learn. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल Sethi Swift Learn सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the question. Question is, the edge of an aluminium cube is 10 centimeter long. One face of cube is firmly fixed to a vertical wall. A mass of 100 kg is then attached to the opposite face of the cube. The vertical deflection of the face is, we have to fill in the blanks. Shear modulus of aluminium is 25 gigapascal and G equal to 10 meter per second square. Concept, applicable and solution. First I will discuss the certain concept. Modulus of rigidity. Modulus of rigidity denoted by eta, that is shearing stress over shearing strain. Shearing stress is when force X tangentially, that is equal to F upon A delta X upon L, delta F upon A delta X upon L. Now for a small distance, for a small deflections, that is theta is small and tan theta equal to delta X upon L can be taken as X. This is all about the modulus of rigidity. Now start with the solution. Now solution of the question. As modulus of rigidity is equal to F upon A, theta भी लिख सकते हैं, F upon A tan theta delta X into L भी लिख सकते हैं. According to question, F equal to 100 kg, 100 into 10, 10 to the 3 Newton. Length 10 centimeter, that is 10 into 10 to the minus 2 meter, that 10 to the minus 1 meter. Then area equal to 10 square centimeter square, that is 10 to the 2 into 10 to the minus 4 meter square, that to 10 to the minus 2 meter square. It is given to you gigapascal, 25 G Pascal, that is 25 into 10 to the 9 Newton per meter square. Right? Now, to find delta X, that is deflection. This is to find out. Substituting values, find delta X will be equal to, delta X will be equal to 4 into 10 to the power minus 7 meter. That will be the answer on simple calculation. I have put up simplified all the values. Just simple calculation is pending. Final answer is this one. Right? Next question. Question is, the compressibility of water is 6 into 10 to the minus 10 SI unit. If one is subjected to pressure of 4 into 10 to the 7 SI unit, the decrease in its volume is, 4 options are given to you, one option is correct. Before start of the question, let's discuss certain concept applicable. Bulk modulus of elasticity, that is B equal to applied pressure divided by applied pressure divided with change in volume. That is P upon delta V upon is negative sign. Minus sign indicates that when pressure increases, volume decreases. As shown here, this is a sphere, surface area given है, pressure apply किया जा रहा है, readily inward, the volume is decreasing, B minus V naught. Similarly, in the cube, volume is decreasing. When body is immersed in a fluid, means pressure is exerted. Hydraulic stress भी कहते हैं different, right? Now, what is compressibility? This is known as volume strain or volume stress. Compressibility, K equal to 1 over B. Reciprocal of bulk modulus of elasticity is known as a compressibility, right? Now, let's start with the solution. Solution of the question is, as we know, K equal to 1 by B and B equal to P upon delta V to V, that is PV equal to delta V. According to question, given a B is given, K is given, compressibility given, pressure is given, volume is given. 1 liter, K is given 6 into 10 to the minus 10, 6 into 10 to the minus 10, SI unit, and this is 4 into 10 to the 7, 4 into 10 to the power 7. 4 into 10 to the power 7. SI unit, SI unit. This is unit. Therefore, to find delta V, now from this equation we can find that is equal to 1 by K. So this comes out to delta V will equal to PVK. PVK. Delta V will be equal to PVK. P put किया हमने 4 into 10 over 7. 4 into 10 over 7. V put किया 1 liter. And this put किया 6 into 10 over minus 10. 6 into 10 over minus 10. This is Newton per meter square. Newton per meter square. This is 1 upon Newton per meter square. This answer will be 24 into 10 over minus 3 liter. Answer is given to CC. As we know, 1 meter cube equal to 10 to 3 liter. 1 liter equal to 10 to the minus 3 meter cube. That 10 to the minus 3 into 10 to the 6 centimeter cube. That 10 to the 3 cc. Therefore, converting to this 24 into 10 to the minus 3 into 10 to the 3 cc. This is goes, that is 24 cc. That is the answer. Let's see the option. Option is B. Option B is correct. Option B is correct. Right? Now, I would like to request, if you are new to my YouTube channel, Sethi Swift Learn, Sethi Swift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.